your Seaford graph salted. Our graphs must have scale, axes, straight ones, a nice label, and most importantly, a title. So, scale must be uniform, go up in even spaces. Vertical axes, horizontal axes. Vertical, really important, we start at 0. The labelling must also include units, and the title really tells us the story of what the graph must convey. The independent variable, often used in science, maths, humanities, must be generally shown along our horizontal axis, often called the x-axis. Our dependent variable is shown on our vertical axis, up and down. For your axes, we must have a clear scale. Often I see students jump 10, 40, 70, 90, because they're the values that are on the table. But these values must be evenly spread in scale increments by the same amount on a grid box or an Excel spreadsheet. Label your units. For example, time along the x-axis is quite a common one. In science and humanities, we might be measuring temperature across a continent or a practical experiment. That often is on our vertical axis. As we said earlier, the title really captures the purpose for the graph. So in this example, we have on our x-axis the different types of movies: comedy, action, romance, drama, not even maths, and sci-fi. People across here, looking at frequency or in some cases percentage, is along our vertical axis. Is this graph salty? Funny you should ask. This one talks about salt. We have a number of drops of salt. We have our water solution side by side. Clearly, the one in blue is showing a different story to our salt water in red. World population. So, 1900, we've got very small population, about 1.7, 1.5, maybe close to 1.7 billion in 1900, just before World War I. We now look at projected model of 2050, 9 billion. We're currently sitting around 7.6, 7.7. So these are our values that we can interpret from our graph. Yet again, we've got a nice title. We've got a nice axes, clear scale, all right, and clear labels to tell us that this graph is, well, in fact, salty. Thank you for your patience.